topic for chapter 3 is the cell cycle. You might remember things like the insect life cycle or other kinds of life cycles. And that's basically what this is for a cell. Cells come from another cell dividing. And if one day that cell divides, its life is the period from when it splits off from what we call its parent cell until it splits into what we call two daughter cells. It's cycle because this point here is the same as this point here. Like how the insects lay eggs, the eggs hatch into larvae, which pupate, grow into adults, which lay new eggs. The main part of the cell cycle where it spends the most time is called interphase. Inter means between. They called it that for between divisions. That doesn't mean it's just sitting there not doing anything. If the cell has a job to do, it's doing that job while it's in interphase. If it's going to divide again, then it does a couple of things to prepare. It has to grow. And that's the G. 3 parts of interphase are G1, S, and G2. In G1, it's mostly growing, and if it has a job, it doesn't. A cell can spend years in G1. It might specialize, meaning it's just going to keep doing its job, and it's never going to divide. It might die. You don't have to worry about this word down here, apoptosis. That's when a cell dies, such as your skin cells that gradually die off as they get closer to the surface. Cells that are going to divide move on from G1 to the S, or synthesis phase, which what they're synthesizing there or building is DNA. They replicate or copy their DNA so that they'll have 2 full sets to give to the 2 new cells. After they replicate the DNA, they go on to G2, where they're going to do the rest of what they need to prepare to divide, such as building special proteins or more organelles or something. And then division itself includes 2 processes called mitosis and cytokinesis.
What's the G2 phase? What does it do in the last phase?
G2 is when it finishes its preparation for dividing, such as building proteins or organelles. And it might grow a little more if it needs to. Most of the growth is going to be in G1. It has to get big enough to be able to divide and have enough substance for 2 cells. Mitosis is the process of dividing up the DNA. So taking one nucleus full of chromatin, turning it into 2 nuclei that both have identical full sets of the DNA. The stages of mitosis are called prophase, metaphase, anaphase, telophase. If you put that together with interphase, you get IPMAT as a way to remember the stages of the cell cycle. If you look at just the stages of mitosis, PMAT, that's something that a Purdue fan might have in front of their door.
Boiler on.
So a couple of definitions so we can more easily talk about what's happening to the DNA in mitosis. Chromosome is one piece of DNA. So it has a beginning and an end and a whole bunch of DNA in the middle. Humans have 46 chromosomes. those 46 separate pieces all together make up the chromatin in the nucleus. A chromatid is a copy of a chromosome. After synthesis, or interphase S, all the chromosomes have 2 chromatids. So we make the copy and we keep the pages together. Replicating DNA is kind of like if you sent a 46-page document to the printers and said, I need one more copy of this. Instead of handing you back 2 copies of 1 through 46, what you get is 2 copies of page 1 stapled together, 2 copies of page 2 stapled together, all the way up to 46. So most of mitosis is spent breaking those staples and making sure you get it organized so you get all of the pages in both sets. You can see chromosomes during mitosis. When you get a really good view, they often look like an X. And that's because of the 2 chromatids. As long as they're attached together, it's still considered 1 chromosome. Prophase. So an interphase cell looks like everything we saw last week, a cell with a nucleus. Prophase, pro is the beginning, think prepare. This is where it has to get ready to divide up those copies. The reason you can't see the individual chromosomes in interphase is they're stretched out so that all the instructions along them are accessible. But leaving it like that is like having a drawer full of extension cords and you want to get one of them out. Not easy to do. So one of the things that happens in prophase is we go through and take each extension cord and coil it up and put a twist tie around it. We call that condensing the chromosomes. We'll just do 4 of them. Second, we need to get them out of that envelope that the copier sent them to us in. And that's the nuclear envelope. So the nuclear envelope breaks up. So by the end of prophase, we've got chromosomes loose in the cytoplasm without an envelope around them. But in order to control them and move them around, we need our centrosomes. Near the end of interphase, the cell makes a second set of centrioles. In prophase, they move to opposite ends of the cell. We call those the poles, and they send out a string, which is a piece of cytoskeleton called a spindle fiber, to attach to each chromosome. the 2-semester version of the textbook has one spot that says this happens in metaphase, but everything else I've seen, including other places in the book, have this as prophase. Metaphase, think M for middle. The centrosomes adjust the spindle fibers to pull the chromosomes into a nice neat line. And that's basically so they can go through and check, okay, I have 1, 2, 3, 4, 5, yada yada, do you have 1, 2, 3, 4, 5, yada yada. We call that the equator. It's in the middle with the poles on the ends. So our cell turned into the entire Earth while it's dividing. Anaphase. Can somebody remember where we saw Anna before? It's in the title of the class, Anatomy, which meant cut up or cut apart. So anaphase is when the chromatids move apart. The centrosomes pull them towards the poles to get 2 separate sets. And then finally, telophase. Telo means terminal, like the end. 2 main things are happening in telophase. One is we're reversing everything we did in prophase, but double. So we're rebuilding 2 nuclei. The other is cytokinesis, which we'll look at next. So I'll just do it like this. We actually call it decondensing when they uncoil and spread back out into thin chromatin. So if we just did mitosis without cytokinesis, you'd get a cell with 2 nuclei. Cytokinesis is the process of dividing up the cytoplasm and the membrane to make 2 separate cells. So there's a ring of cytoskeleton, I got too specific on here and said microfilaments, around the center that's going to pinch in like a boa constrictor, pull these ends closer and closer together. So it gets like that. Until it finally splits into 2 new cells, and those cells are back in interphase. Sometimes you can see a little bit of cytokinesis starting in anaphase, but it's most noticeable in telophase, and the completion of cytokinesis is when we count the end of cell division and moving into the 2 daughter cells in interphase. So I picked out a nice basic animation. I'm not happy that they misspelled telephase, so it says tele like television, which means far, not the end. But what happens in it is good. There are a lot more animations on YouTube. Some of them go into more detail. If you like videos as a way to learn, you can just go in and search and see what you find. Questions on the cell cycle?